The James Webb Space Telescope has already changed everything we thought we knew about the universe. With its massive golden mirrors and instruments capable of peering deeper into time than any observatory before it, Webb has delivered breathtaking images of galaxies, stars, and worlds billions of light years away. But while Webb was designed to study the distant cosmos, sometimes its greatest surprises come from much closer, within our own solar system and beyond. Recently, Webb turned its attention to an object unlike any other, a wandering visitor from interstellar space, 3I ATLA. This mysterious body has already stunned astronomers by defying expectations, but Webb's latest observations revealed something that should be impossible. For a brief moment, 3I ATLA appeared to move faster than the speed of light. To understand why this discovery is so shocking, you must first understand what 3I ATLA is. This is not just another asteroid or comet from the outer reaches of our solar system. Like its famous predecessors Oumuamua and 2I Borisov, ATLA is an interstellar interloper, a fragment from another star system drifting across the void and now passing through ours. These objects carry secrets of alien worlds, born in distant stellar nurseries, shaped by suns that are not our own. But nothing in physics should allow them, or anything, to move faster than light. According to Einstein's theory of relativity, the speed of light is the universal limit. Nothing with mass can cross it. So how could James Webb record such a phenomenon? Was it an error, an illusion, or something far stranger? The answer may rewrite the very laws of physics. What is 3I ATLA? Discovered in 2019 by the ATLA survey in Hawaii, 3I ATLA was initially catalogued as a comet-like object on a highly unusual trajectory. Unlike the asteroids and comets that orbit the Sun, ATLA came in from deep space and is now heading back out, never to return. Its path is hyperbolic, meaning it is not bound by the Sun's gravity. In simple terms, this is a visitor from beyond, a messenger from another star. It is only the third known interstellar object ever detected, following the cigar-shaped Oumuamua in 2017 and the icy comet Borisov in 2019. But even among this rare class, ATLA is strange. It appears larger and more chaotic than either of its predecessors, with a fractured nucleus that seems to shed material as it travels. Astronomers hope James Webb could help unravel its secrets. By analyzing the light reflected and emitted by ATLA, Webb could determine its composition, its origins, and maybe even which star system it came from. But when Webb's instruments tracked it across the sky, the data revealed something bizarre. For moments at a time, ATLA seemed to jump across space faster than any natural body should move. The telescope's readings suggested motion beyond the cosmic speed limit. At first, scientists thought this must be an error in calibration, but after checking and re-checking the data, they realized the anomaly was real. ATLA was producing signatures that mimicked superluminal motion faster than light. This left astronomers with a mystery that cut to the core of physics itself. How could a fragment of rock and ice from another star behave in a way that defies relativity? Unless, of course, what Webb saw was not just a rock. The speed of light barrier. To grasp the magnitude of Webb's observation, you must first understand why the speed of light is so absolute. Einstein's theory of special relativity states that nothing with mass can reach or exceed light speed. As an object accelerates, its energy requirement grows infinitely larger as it approaches the limit. To move faster than light would require infinite energy, something the universe itself does not allow. For more than a century, this principle has been tested again and again, from particle accelerators on Earth to the orbits of stars near black holes. And every test has confirmed it. Light speed is the cosmic speed limit. Yet there are rare exceptions, at least in appearance. Sometimes particles traveling slower than light can seem to move faster under certain conditions. In quantum physics, entanglement allows information to appear instantaneously linked across vast distances, though no mass actually travels faster than light. In astronomy, objects like quasars or pulsars can appear to move faster than light because of relativistic jets and perspective effects. These are illusions, not reality. So what did Webb see with 3i ATLA? Was it an optical trick caused by the way light reflected off its fragments? Or was it something more extraordinary, a genuine violation of the light barrier? The troubling part is that Webb's instruments are not easily fooled. The telescope's sensitivity and precision are unmatched. For ATLA to mimic superluminal motion, something highly unusual must be happening in or around it. If the anomaly is real, it means one of two things: either our understanding of relativity is incomplete, or 3i ATLA is not behaving like a natural object at all. The disturbing possibility of artificiality: when Oumuamua passed through our solar system in 2017, some scientists suggested it might not be natural. Its elongated shape, lack of a cometary tail, and sudden acceleration led Harvard astronomer Avi Loeb to propose it could be an alien probe. The idea was controversial, but it opened the door to considering interstellar objects as potential artifacts. Now, with 3i ATLA, those suspicions return. The superluminal signature recorded by Webb is difficult to explain through ordinary physics. Natural objects do not jump across space in ways that mimic faster than light motion. But a piece of advanced technology, designed to manipulate light or gravity, might. Could ATLA be more than shattered comet debris? Could it be a craft, or a fragment of one, designed by intelligence far older and more advanced than humanity? If so, its strange behavior may not be a mistake, but a signal. Some researchers propose that the fractured appearance of ATLA could conceal a structure, not just a rock. Others wonder if the anomalous readings are the result of exotic propulsion, something that bends space itself. Of course, mainstream astronomy is cautious. Extraordinary claims demand extraordinary evidence, but the fact remains: Webb detected something it should not have. Whether illusion or reality, the anomaly forces us to reconsider what ATLA truly is. If natural, it challenges the very foundation of physics. If artificial, it confirms a possibility long imagined but never proven: that we are not alone, and the universe is seeded with technology far beyond our own. What happens next? The James Webb team now faces one of the greatest puzzles in astronomy. How do you investigate an interstellar visitor that is already on its way out of the solar system, never to return? ATLA is moving fast, and opportunities to study it are vanishing by the day. Additional telescopes are being tasked to observe it from Earth and orbit, comparing their data with Webb's. If the anomaly can be replicated, it will rule out error and confirm that ATLA is producing superluminal signatures. But if Webb alone records the effect, the mystery deepens further, suggesting the telescope's unique sensitivity uncovered something invisible to others. Meanwhile, physicists are scrambling to model explanations. Some suggest fragments of ATLA are reflecting sunlight in unusual ways, creating an optical illusion. Others believe gravitational lensing, light bending around massive objects, may be involved. But there is also the unsettling theory that ATLA carries exotic materials or structures capable of manipulating light itself. The stakes are enormous. If Webb's readings are correct, then humanity has witnessed either the greatest illusion in space science or the first hint that the laws of physics are not what we thought. And if ATLA is not natural, then we may have just glimpsed the technology of another civilization drifting silently through our skies. The universe has many mysteries, but this one may prove the most dangerous of all. The debate among astronomers. When Webb's data was released to a small circle of researchers, the reaction was immediate and divided. Some astronomers dismissed the readings as calibration errors. Others admitted, with hesitation, that the signals were unlike anything they had ever seen. Conferences became battlegrounds of ideas. On one side stood the traditionalists, clinging to relativity as unbreakable. They argued the anomaly must be an illusion caused by fragmentation of ATLA or by software misinterpreting rapid changes in brightness. On the other side stood the radicals. Those who believed the universe still had secrets capable of surprising even Einstein. What unsettled many was that Webb is no ordinary telescope. Its instruments are meticulously calibrated, its data cross-checked by some of the finest minds on Earth. Errors are possible, but unlikely. If Webb says ATLA moved in ways that suggest faster than light motion, the possibility cannot be ignored. Behind closed doors, a deeper question circulated: what if ATLA is not simply a comet, but something engineered? Few dared say it aloud, fearing ridicule. Yet the ghost of Oumuamua lingered. If one interstellar visitor had behaved strangely, perhaps another could too. The debate rages on with no consensus. But one fact is clear: whatever 3I Atlas is, it refuses to behave like a normal rock from space. It has become a mirror reflecting humanity's hopes, fears, and unshakable need to understand the unknown. Faster than light illusions in space to many physicists, Webb's data immediately brought to mind a phenomenon known as apparent superluminal motion. In certain cosmic environments, objects can appear to travel faster than light without actually breaking the laws of physics. This effect is often seen in quasars and active galactic nuclei. When jets of matter propelled by black holes at nearly light speed are angled toward Earth, the combination of velocity and perspective can make them look as if they are outrunning light itself. It is an illusion, but a convincing one. Could something similar be happening with 3I Atlas? Perhaps fragments of its nucleus are being ejected at extreme speeds, and from Webb's vantage point, they seem to leap ahead faster than light. If so, the anomaly could be explained by geometry, not exotic physics. But there is a problem. Atlas is not a quasar. It is not powered by a black hole. It should not produce relativistic jets. To mimic superluminal motion, its fragments would need acceleration on a scale no natural process can easily explain. Even violent outgassing from a comet cannot account for the precision of Webb's measurements. This leaves researchers in a bind. Either ATLA is producing an illusion with a mechanism we do not yet understand, or the object itself is interacting with space-time in ways that go beyond our physics. Both possibilities are unsettling. For now, the illusion hypothesis is the safer explanation. But the more Webb observes, the harder it is to dismiss the possibility that ATLA is something far stranger. Exotic matter and warp physics. If 3I Atlas is truly producing effects that mimic faster than light travel, then perhaps the answer lies not in illusion but in exotic physics. Theoretical models in cosmology allow for strange substances and forces that could bend the rules. Physicists have long speculated about exotic matter, substances with negative mass or negative energy density. These materials, if they exist, could warp space-time itself. The famous Alcubierre warp drive concept relies on negative energy to compress space ahead of a vessel and expand it behind, effectively allowing faster than light travel without breaking relativity. Could fragments of ATLAS contain such exotic matter? If so, their interaction with sunlight or cosmic radiation might distort the space around them, producing signals that Webb interpreted as superluminal motion. Skeptics caution that no evidence of exotic matter has ever been found. But then again, until 2017, no one had ever detected an interstellar object either. Each discovery stretches the boundaries of what is considered possible. If ATLAS does contain exotic materials, it may not be natural. Stars do not forge negative energy in their cores. Instead, this might be the signature of technology, crafted intentionally, perhaps by a civilization that learned to manipulate space-time. It sounds like science fiction, yet Webb's data hints that what we once dismissed as fiction may simply be physics we do not yet understand. The messenger hypothesis, among the more daring theories, is the idea that 3I Atlas is not a random wanderer, but a messenger. When Oumuamua passed through our system, its strange acceleration prompted speculation that it was a probe designed to gather information. ATLAS's anomalous behavior raises the same question. What if ATLAS is not debris but a vessel, damaged, fractured, yet still functioning? Its chaotic fragments might be the remains of a craft once whole. Its apparent superluminal jumps could be artifacts of propulsion systems struggling to operate after eons in deep space. Even its timing is curious. Humanity has only recently developed the technology to detect interstellar visitors. What are the chances that within just a few years we have seen 3? Are we suddenly lucky, or are these objects appearing now for a reason? If ATLAS is a messenger, its message may not be intentional. Perhaps it is simply drifting, carrying within its fragments the technology and materials of another world. But perhaps its presence is deliberate. A probe sent long ago, now arriving just as humanity takes its first steps into interstellar awareness. Mainstream scientists scoff at the idea, but the messenger hypothesis has captivated the public. Because if true, ATLAS is not just a rock. It is a story written in stone and ice, traveling for millions of years, finally arriving at our doorstep. Humanity faces the unknown. Whatever 3i ATLAS is, one truth remains: humanity is standing on the edge of a mystery as vast as the stars. Webb's data has challenged physics, sparked debate, and forced us to reconsider what we know of space. If ATLAS is natural, it is revealing new processes we do not yet understand. If it is artificial, it is the first evidence that we are not alone. In either case, the implications are staggering. For centuries, humanity has dreamed of traveling beyond the stars, of encountering other civilizations. Now, fragments from those distant worlds are coming to us. They bring no greetings, no explanations, only riddles carved in light and motion. The debate is far from over. New observations will come, theories will rise and fall, and the mystery of ATLAS may never be fully solved. But perhaps that is the point. The cosmos does not owe us answers. It only offers questions. Questions that test our imagination, our courage, and our humility. The James Webb Space Telescope was built to peer into the unknown. With 3i ATLAS, it has done exactly that. And in doing so, it has reminded us that the universe is stranger, darker, and more wondrous than we ever dared believe. The response of space agencies: as soon as the data from Webb was confirmed, space agencies around the world began to take notice. NASA released a cautious statement describing the readings from 3i ATLAS as anomalous and in need of further investigation. The European Space Agency echoed this language, careful not to imply anything extraordinary. Behind the careful wording, however, was a clear undertone of concern. Private briefings revealed that scientists were split. Some urged caution, insisting the anomaly was likely an illusion caused by ATLAS's fragmentation. Others believed it demanded urgent study, warning that if the readings represented real physics, then humanity had just glimpsed phenomena that could change everything. The question was simple but urgent: how do you study a visitor already on its way out of the solar system? Proposals emerged for a rapid probe mission, similar to the plans once drawn up for Oumuamua. But the timelines are brutal. By the time such a probe could launch, ATLAS may already be beyond reach. This urgency sparked tension. If ATLAS holds secrets of faster than light physics, missing it would be one of history's greatest lost opportunities. Governments quietly began funding think tanks, asking not only what ATLAS is, but what it could mean for future technology. For now, space agencies remain cautious in public, but the reality is clear. They are watching ATLAS with every tool available, aware that its secrets may slip away forever into the dark. Public fascination and fear. When news of Webb's discovery leaked to the public, fascination spread like wildfire. Headlines screamed of an interstellar object breaking the speed of light. Social media exploded with theories, some scientific, others wild and conspiratorial. Was ATLAS proof of aliens? Was it a cosmic weapon? Was it the harbinger of disaster? For many, the idea was thrilling. Humanity had spent centuries searching the skies for signs of other worlds. Now, perhaps, those worlds were sending us messages in stone and light. Artists and writers flooded the internet with depictions of alien probes and interstellar vessels. The story of ATLA captured imaginations in a way no comet or asteroid ever had. But for others, the news brought fear. If an object could move faster than light, what else might be possible? Could ATLA be dangerous? Could it crash into Earth, or worse, be deliberately observing us? Religious groups called it a sign of prophecy. Skeptics warned against hysteria, insisting that scientists were being misinterpreted. The truth was simple: no one really knew. Webb had revealed something that defied explanation, and in the absence of certainty, the human mind filled the void with hope, dread, and wonder. In coffee shops, lecture halls, and living rooms, people argued about ATLA. For once, the mysteries of the cosmos were not distant abstractions. They were here, in our solar system, forcing us to confront the possibility that reality itself is stranger than we imagined. Could it be a signal? Among the boldest theories about ATLA is the idea that its behavior is not random. What if the apparent faster than light jumps are not accidents, but intentional? What if ATLA is not simply moving, but signaling? Some researchers noted that the anomalies in Webb's data occurred in bursts, repeating in intervals. To them, this pattern looked less like chaotic physics and more like communication. Could ATLA be transmitting information using light, coded in a way we do not yet understand? If so, the implications are staggering. Humanity has long searched for signals from intelligent civilizations, pointing radio telescopes into the sky for decades. But what if the signal is not coming to us across space, but delivered physically in the form of an interstellar object? A messenger not of waves, but of matter itself. Of course, skeptics push back. They argue the bursts are statistical artifacts or reflections from fragments tumbling unpredictably. They warn against interpreting randomness as design. Yet the possibility lingers, haunting every debate. If ATLA is a signal, then who sent it? And why now, at this precise moment in our technological development? Perhaps it is coincidence. Or perhaps, after eons of silence, the universe has decided to speak, and James Webb has heard the first whisper. The existential implications, whether ATLA is natural or artificial, its mystery forces humanity to confront profound questions. If it is natural, then it reveals processes in the universe that we do not yet understand. Processes capable of mimicking faster than light motion, challenging the very foundations of physics. If it is artificial, then the implications are even greater. It would mean we are not alone, and that other civilizations mastered technologies we cannot yet imagine. Either way, humanity stands at a crossroads. The discovery compels us to ask, what is our place in the cosmos? For centuries, we believed ourselves unique, isolated on a small blue world. But the interstellar visitors that now cross our skies suggest otherwise. The universe is dynamic, alive with wanderers and mysteries that refuse to fit neatly into our textbooks. Some philosophers argue that ATLA is a reminder of humility. We are young, barely scratching the surface of cosmic knowledge. If civilizations older and wiser exist, their remnants may drift silently through space, waiting to be noticed. Others fear the implications. If ATLA is a relic of alien technology, then it proves such civilizations can fall. What destroyed them, and could the same fate await us? The chamber beneath the Sphinx held warnings carved in stone. The stars, it seems, may hold warnings carved in ice and light. Atlas, whatever it is, forces us to face the possibility that our understanding of reality is fragile, and that our future depends on how we respond to the unknown. Governments moved quietly as debate raged in the scientific community and fascination spread among the public. Governments began to act more discreetly. Intelligence agencies quietly requested access to the Webb data. Defense departments asked whether 3I Atlas posed any threat. If an object could mimic faster then light motion. Could it also carry something unknown? Something dangerous? Whispers emerged that specialized teams were modeling potential scenarios. If ATLA were artificial, could it contain dormant technology? Could it awaken or release signals as it passed through the solar system? Some speculated about the possibility of surveillance, others about weaponry. Official statements remained calm, insisting there was no danger, but behind the scenes urgency grew. Meanwhile, astronomers worried that too much secrecy would harm the pursuit of truth. If governments classified Webb's data, the opportunity to understand ATLA would be lost to bureaucracy. Already some parts of the dataset had been withheld, fueling suspicion that more was being discovered than revealed. The struggle between transparency and control defined the moment. Was ATLA a purely scientific mystery to be studied openly? Or was it a matter of national security to be hidden until its nature could be understood? For now, humanity's knowledge of ATLA depends on what governments choose to reveal. And as history shows, secrets of this magnitude rarely stay hidden forever. Preparing for the next encounter, perhaps the most sobering realization is that ATLA will not be the last. In just a few short years, humanity has observed 3 interstellar visitors, Oumuamua, Borisov, and now ATLA. That suggests such objects are not once-in-a-lifetime events. They may pass through our system more often than we ever imagined, unnoticed until now. This raises a pressing question. What if the next one is even stranger? What if the next does not simply pass through but slows down, lingers, or even changes course? Would we be ready to respond? Space agencies are already discussing new strategies. Some propose a dedicated mission, an interceptor probe on permanent standby, ready to launch at a moment's notice when the next interstellar visitor appears. Others suggest building telescopes specifically designed to track fast-moving objects from deep space. But preparation is not only technical, it is philosophical. Humanity must prepare for the possibility that the next visitor could confirm our wildest theories. If ATLA is a messenger, then another may carry a clearer message. If ATLA is an illusion, the next may confirm or refute it. Either way, we must be ready. The James Webb Space Telescope has shown us what is possible. Now, it is up to us to decide how far we are willing to go to meet the unknown. Standing at the edge of the unknown, in the end, 3i ATLA may never reveal its full story. It is already moving beyond the reach of our instruments, fading into the endless dark between stars. Perhaps we will never know if it was a fractured comet, an alien probe, or a signal written in light, but the mystery it leaves behind is as important as the answers we sought. ATLA reminds us that the universe is not static. It is alive with travelers, wanderers, and enigmas that defy our understanding. Each interstellar visitor is a message that we are not isolated, that we are part of a wider cosmic story we barely comprehend. For scientists, ATLA is a challenge to physics itself. For dreamers, it is proof that the universe still holds wonders. For governments, it is a puzzle of security and secrecy. And for humanity as a whole, it is a mirror, reflecting our fears, our hopes, and our endless curiosity. We stand at the edge of the unknown, staring into the vastness, uncertain of what comes next. Perhaps ATLA was only a fragment of rock. Or perhaps it was the first whisper of a greater truth, that faster than light travel is possible, and that others have already mastered it. The James Webb Telescope has opened a window we cannot close. The question is, are we ready for what comes through?